Assalamualaikum warahmatullahi wabarakatuh. Okay, with me Hasbiullah. On this occasion, we will focus our mind on a brief discussion about power generation with biomass as a fuel. Have you ever heard of the term of biomass? Incredible source of energy which is found in living things around us. Energy sources are very abundant, but how do we process them to meet our electricity needs? Okay, let's start it. We start from combined heat and power plants. In combined heat and power plants, both electricity and useful heat are generated in one power plant. The heat can be utilized for industrial or district heating. A typical district heating system has two pipelines going to the user property. The first one delivers the hot water to heat exchanger located in user property. In the heat exchanger, the thermal energy transfer from district heating water to heat transfer medium located on central heating system. The second pipelines return from customer to CHP plants, bringing back cold water to reheating. Biomass has its advantage as a renewable fuel, having capability to rebind and use carbon dioxide produced and release it to the environment. However, biomass is not completely straightforward, and several techno-economical issues have to be considered. The first, availability and price of biomass depend on location of plants. The second, relatively high cost for harvesting, transportation, and storage caused by low energy density. And the third, technical challenge related to the use at the plants, including conveying energy and combustion caused by impurity, biomass, and ash. But the important is how to generate the electricity. There are many types of CHP plants, but the principle of all of them is still the same. First, heat produced in combustion is converted to kinetic energy in turbine and to electricity in generator, and the remaining thermal energy is transferred to heat transfer medium used, for instance, or for district heating. There are many configurations and technology to collection heat during power generation in useful form. One way is to use steam power plants, where fuel is combusted in boiler or furnace, that is, the heat transported to heat exchangers such as superheater to water cycle. In the heat exchanger, high pressure steam produced. That steam runs through a steam turbine which transforms kinetic energy to electricity in a generator. Although the above-mentioned technology can generate electricity and heat, all of them use liquid or gaseous biofuel. It has to be recognized that gaseous or liquid biofuel are relatively rare. Liquid and gaseous have very limited availability and are usually more expensive. These fuels are technically even better than solid biomass, but due to the price and availability, these fuels considered as marginal fuel for CHP production. Therefore, a steam power plant is the main technology of CHP production, and several variations for combustion solid biomass have been developed. For cogeneration of heat and power from solid biomass, the steam power plants are commonly used. A typical CHP plant with steam cycle consists of: first, boiler combusting solid fuels such as biomass or waste, and then transfer thermal energy via heat exchanger to the water. Second, a steam cycle with steam turbine. The third, a generator to produce electricity, and then the other heat exchanger to transform the low temperature heat to district heating network. Okay, let's see this figure. This figure is illustrate the simplified scheme of steam cycle power plant to generate electricity and heat for district heating. There are two well-suiting technologies that can overcome the technical challenge related to biomass combustion. fluidized bed boilers and grate-fired boiler. Grate-fired boiler have been used for a long time, and the grate can be designed for various different biomass type. In grate-fired boiler, a biomass fed on a fixed or mechanical grate that can have a sloping structure to facilitate the moving biomass when combustion. In grate-fired boiler, biomass is fed on the grate, and air is fed through on top of the grate. Biomass ash is removed from the end or the bottom of the grate. Fluidized bed technology, on the other hand, has been used since 1970 in boiler. In fluidized beds, a solid heat transfer medium such as sand is fluidized with the air from the bottom of boiler, creating a fluidized bed together with biomass particle, and flue gases form in combustion. The basic concept of electricity generation is located in turbine and generator. The blades from this turbine will be driven by fluid produced from combustion. It causes a turbine to spin, which will produce the work. This work is sent to generator by rotating shaft connection. Okay, now consider this picture. Example for biomass power generation process. We note this right. The generator is attached to the turbine, and when the turbine blades rotate, it makes generator work on the principle of magnetic induction and create electricity. The method of retrieving electrical energy is depend on how it will be used, and finally electricity is distributed to the people. And now we have learned some knowledge about biomass power plants. The first, combined heat and power plant functions, advantage of biomass, typical of CHP plants, an important part of CHP plants, two well-suiting technologies of CHP plants, and the last, the basic concept of electricity generation. Okay, thank you for watching. Assalamualaikum warahmatullahi wabarakatuh.